Bismillahirrahmanirrahim. Assalamu alaikum. Today we will start chapter number 5, whose title is Numerical Integration. So integration numerically will be dealt in this chapter. There are some hints for you guys. The first one is closed interval. Closed interval is the set of all the values between two real numbers a and b, including those two real numbers a and b. Closed interval can be denoted by enclosing a and b in square brackets, or you can represent this interval in this form, that x lies between a and b. So that is a closed interval. This is the set of all the values between a and b, including a and b. A is included and b is also included, so this is called closed interval. The second one is open interval. So if we remove these endpoints from the interval, if we remove a and b and include all the points between a and b, so that is called open interval. Just like that, we remove this a, we remove this b, and all those numbers between a and b are included, so this is called open interval. This open interval is denoted by a comma b within parenthesis, or you may write this interval in this form by reversing the square brackets, or you may write this interval in this form, that x lies between a and b, but a is not included because there is no equal sign here. And this closed interval, equal sign is there, that a is included, equal sign is there, so b is included. But in open interval, a and b are excluded, so that's why there is no equal sign. The third one is if we divide an interval into n equal parts. For example, this is an interval a b, and we are going to divide this interval into n equal parts, say from x0 to x1, that is one part, so we may say that that is the subinterval of this whole interval. And secondly, from x1 to x2, that is the second subinterval, and from x2 to x3, that is the third subinterval, and so on. So if we divide this whole interval from a to b into equal subintervals, so that is called the division of this interval into n equal subintervals, and that is the integration, that is integral sign. So integral from a to b, we read this as integral from a to b f of x with respect to x is called definite integral, and this definite integral, this a is called the lower limit, and that b is called the upper limit. And what is the value of this definite integral? We can calculate this value from the definition, and now in this chapter we will find the numerical value of this integral. Numerical value of this integral means that we are going to find the approximate value of this definite integral. So the process of finding the approximate value of this definite integral is actually the numerical integration. So that is called the numerical integration. Remember that in this chapter we will deal all those calculations which are related with the approximate value of this integral. So how could we find the approximate value of this integral? Throughout this chapter there are some certain techniques, and those techniques are called Newton-Cotes formulas. Newton-Cotes formulas, remember that. So that is, the following formulas are called Newton-Cotes formulas for approximating the value of this definite integral. That is, to find the approximate value of this definite integral with the help of Newton-Cotes formulas. The first Newton-Cotes formula is called Trapezoidal Rule. The second one is called Simpson's 1/3 rule. The fourth one is Simpson's 3/8 rule. The fourth one is Boole's rule. and the last one is Weddle's rule. So in this chapter we will be dealing all those we will deal all those 5 techniques to find the numerical value of this definite integral. So all those 5 formulas will be used to find the approximate value of that definite integral. So first of all, we will discuss here trapezoidal rule. That what is trapezoidal rule? So the basic steps for calculation for calculations for calculations of this definite integral by trapezoidal rule are as follows. The first one is you'll be given some data. I mean, you will be given the value of a, this lower limit, the value of b, this upper limit, and the value of f of x, the value of that function, and n, that in how many subintervals are you going to split this interval a to b. So n will be given 1, 2, 3, 4, where n starts from 0 and so on and so on. So this data will be given to you people. Second one is we need to calculate the step size. The step size mean that what is the size of a subinterval. What is the size of a subinterval? That is from x0 to x1. What is this step size? Or from x1 to x2 and so on. So calculate the step size, and step size is normally denoted by h in your book, and h will be calculated by this formula: upper limit minus lower limit divided by n, divided by this n. So calculate h by this formula. The third one is we need to construct a difference we need to construct a table, not a difference table but a table which gives us the values of all those xi's, I mean x0, x1, x2 up to xn. So and secondly, corresponding to these values of x, the values of f0, f1, f2 and fn. So for calculating these values we will construct a table, not a difference table but a table to calculate these values. And remember that these 3 steps will be used in all the 5 techniques: in trapezoidal rule, in Simpsons 1/3 rule, and Simpsons 3/8 rule, and Boole's rule, and Weddle rule. And all those rules, these 3 steps will be followed. So these 3 steps are common in all the techniques. Remember that this step is different for all the techniques, because the formula for trapezoidal rule, that will be different from the other methods. So the formula for trapezoidal rule is this thing, that is the approximate value of this definite integral, because we are going to find the approximate value of the definite integral. So the approximate value of this definite integral is equal to h by 2. Remember this, h by 2, that is trapezoidal rule. H by 2 multiplied by all fi's, multiplied by f0 plus f1 plus f2 plus fn and so and so. So we see that f0 and fn, that is the first value of the function, and that is the last value of the function. So first value plus last value, and plus 2 times the sum of all the function values, f1 plus f2 and so on. So that is trapezoidal rule. That is the formula for trapezoidal rule. So the last one is we need to put the values of h, and all those fi's to compute the approximate value of this definite integral. So putting all those values, the value of h and those fi's, to get the approximate value of this definite integral by trapezoidal rule. And this trapezoidal, because this is numerical integration, so definitely there will be some error in the value of this definite integral. So in order to find that error, that is called actually global error and trapezoidal rule. Now this error will be calculated by this formula, error and trapezoidal rule, ET, that will be calculated by minus times b minus a, upper limit minus lower limit, divided by 12 multiplied by h square into f double prime x. So you can calculate error if you are asked to find the error and trapezoidal rule. So put the value of a, b, h and f double prime in this formula to get the required error and trapezoidal rule. The second one is Simpson's 1/3 rule. What is Simpson's 1/3 rule? So the following steps will be used to calculate the value of this definite integral with the help of Simpson's 1/3 rule. So what are those steps? The first one is, as discussed in the previous slide, that you will be given some data. You will be given the value of a, b, f of x and n. So that step is the same as discussed in trapezoidal rule. The second step is also the same, that calculate the value of h, calculate the value of the step size which is noted by h, and that is the same as of trapezoidal rule, b minus a divided by n. The third step is again the same. You need to construct a table if the table is not given to you people. So construct the table with the help of calculator in order to find the values of x0, x1, x2 and the corresponding values of function f0, f1, f2 and so on. So these three steps are the same as discussed in trapezoidal rule. The fourth step is different because this step contains the formula for Simpson's 1/3 rule. So the formula for Simpson's 1/3 rule is different from trapezoidal rule, and that is this formula. In order to find the approximate value of this definite integral by Simpson's 1/3 rule, that will be equal to h by 3. And trapezoidal rule there were h by 2, but in Simpson's 1/3 rule this is h by 3. H by 3 because of this 1/3. I mean multiply h by 1 by 3. So that is h by 3 multiplied by f0 plus fn. F0, the first value of the function, plus fn, the last value of the function. So add these two values, plus there is 4 and there is 2. 4 will be multiplied with the sum of those function values whose subscript is odd. You see, 4 is multiplied with f1 plus f3 plus f5 plus f7 plus f9 plus f11 and so on. So the sum of all those function values whose subscript is odd, so 4 will be multiplied with that sum. And similarly 2 will be multiplied with the sum of those function values whose subscript is even, 2, f2, f4, f6, f8 and so on. So 2 will be multiplied with those function values and 4 will be multiplied with the sum of odd subscript of function values. So this is called Simpson's 1/3 rule. Finally, we need to put in this formula the value of h and the values of those all fi's to get the approximate value of this definite integral by the use of Simpson's 1/3 rule. So as this value is the approximate value, so definitely there will be some error, and in Simpson's 1/3 rule the global error is defined to be this thing. that is actually es, because of Simpson this should be written as es. So es will be equal to minus times b minus a divided by 90 multiplied by h power 4 multiplied by the fourth derivative of the function. Remember that Simpson's rule is valid when n is even. This n will be given to you. So Simpson's 1/3 rule is applicable when n is even. So that is Simpson's 1/3 rule to calculate the value of this definite integral. Now the third one is Simpson's 3/8 rule. How could we calculate the approximate value of this definite integral with the help of Simpson's 3/8 rule? The following steps will be applied. The first step is the same, that is the old story, that these values will be given to you. The value of a, b, f of x and n, these will be given to you. Second story is the same, the old story, that you need to calculate the value of h, the step size, by this formula. The third story is again the same, you need to construct a table if it is not given to you people to calculate the values of those function values. The fourth one step is different from the previous two because this is the formula which is called the Simpson's 3/8 formula, and this is what we called Simpson's 3/8 rule formula, that the value of this definite integral is equal to 3/8 times h, because this is 3/8, this is 3/8 rule. So this is 3/8 times h multiplied by f naught plus fn, that is the starting value of the function plus the last value of the function, plus there is 3 and there is 2. So 3 will be multiplied with this sum and 2 will be multiplied with this sum. So what are those sums? We see that this sum is the function values whose subscript is the multiple of 3, that is the table of 3. 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12, 3 fives are 15, and so on. So 2 will be multiplied with those with the sum of those function values whose subscript are the multiples of 3, that is the table of 3, and 3 will be multiplied with the rest of the function values. 3 will be multiplied with the sum of the rest of the function values. What are the rest of function values? F naught is there, so there is f1, then f2, f3 is there, so there is f4, then f5, f6 is there, so that is f7, f8, f9 is there, then and so on. So this is called Simpson's 3/8 rule to find the approximate value of this definite integral. Remember this formula. Finally, we will put the value of, that is the same step as we have studied in previous slides, that we need to put the value of h and the values of all those function values. Put all those values to calculate the approximate value of this definite integral. The fourth one is called Boole's rule. So what are the steps to find the approximate value of this definite integral by Boole's rule? This step, the first step, is the same, that is the old story. Second step is the same, that is the old story. Third step is again the old story. that construct the different the table to find the values of those xi's and fi's. The fourth step will be different because this is the formula for Boole's rule. So the formula for Boole's rule to calculate the approximate value of this definite integral is given to be this thing, that is, the approximate value of this definite integral is equal to 2 by 44 times h. You may say 2h by 45. So 2h by 45, remember this fraction, this will be included in Boole's rule, 2h by 45, then multiplied by, so there are 7, 32 and 12. 7 will be multiplied with the sum of first and last values of the function. The sum of first and last values of the function will be multiplied by 7, and 32 will be multiplied with the sum of those function values whose subscript is odd, 1, 3, 5, 7, 9, 11 and so on, and 12 will be multiplied with the sum of those function values whose subscript is even, that is 2, 4, 6, 8, 10, 12 and so on. So this is called Boole's rule to calculate the approximate value of this definite integral, and this step is the same as discussed previously, that put the value of h and those all fi's to get the approximate value of this definite integral. So this is Boole's rule. And the last one is called Weddle's rule. So what is Weddle's rule? To calculate the value of this definite integral, there are steps. The first step is the old story. Second step is the old story. Third step is the old story. And fourth step is the new story, because this is the formula for Weddle's rule. So the formula for Weddle's rule to calculate the approximate value of this definite integral is this one, and we see that there is 3h by 10. There is 3h by 10. This is different in Weddle's rule. So remember this 3h by 10. 3h by 10 times this sum. And what is this sum? This is actually f naught plus fn. F naught is the starting value of the function and fn is the last value of the function. So sum these two function values. Then there are function values f1, f2, f3, f4 in the same sequence, 5, 6, 7 and so on and so on. So we see that what are those multiples? Those multiples are 5, 1, 6, 1. What does it mean? 5, 1, 6, 1. Again 5, 1, 6, 1. Again 5, 1, 6, 1. Again 5, 1, 6, 1 and so on and so on. So this is called Weddle's rule to calculate the approximate value of this definite integral. Finally put the values of h and all those fi's to get the approximate value of this definite integral with the help of Weddle's rule. Now in order to practice all those techniques, I mean to practice trapezoidal rule, Simpsons 1/3 rule, Simpsons 3 by 8th rule, then Boole's rule, and the last one is Weddle's rule, we have got just one example to understand the idea of those methodologies. Example is there. You are asked to compute, to find the value of this definite integral, because limits are given to you. Limits are from 0.0 to 0.6 and the function is sine x. So we need to calculate the approximate value of this definite integral for n is equal to 6 by the use of all those techniques which we have studied previously, all those rules. So let's see. that how could we use those methods to find the approximate value of this definite integral when n is equal to 6. So the first one is we have studied that there are 3 steps which are common in all those techniques. So the first 3 steps will be for all these 5 methods. The first step is we need to compare this integral which is going to be computed. So compare this integral with the integral from a to b f of x with respect to x. So compare this integral with this one. We get a equals to 0.0, b equals to 0.6, and f of x equal to sine of x from these integrals. So a is equal to 0.0, b is equal to 0.6, and f of x is equal to sine x. 1, 2, 3 values are there, and the fourth value n is equal to 6 is given to you, which is equal to 6. So these 4 values are given to you. The second step is we need to calculate the step size h with the help of this formula. So h is equal to b minus a divided by n. b minus a 0.6 minus 0.0 divided by n. N is equal to 6 here. So replacing these values, we'll get h is equal to 0.1. So the step size is 0.1. The next step is we need to calculate the values. We need to construct a table with the help of calculator. So how could we construct a table with the help of calculator? We have studied in the previous one lecture that how could we use a calculator to construct a table for a function. So let us start that technique again here in this question. In order to construct a table for this function f of x equal to sine x, because this is trigonometric function, so try to keep your calculator in radian mode. We see here that in this display there is d, which is shown here, that is d. So it means that your calculator is in degree mode. So we need to convert this degree mode into radian. So press this mode with the help of shift. Press shift, then mode. We see that there are options related with these keys. Degree is related with 3 and radian is with 4. So press 4 and then equal sign. You see that this display shows that your calculator is now in radian mode. R is there. So calculator is in radian mode. Now we need to construct the table for this function sine x. How could we construct a table for a function? You need to press mod key. Displays there. There is one option, table, and this table is associated with 7. So 7, press 7. The calculator will ask from you that what is f of x. So we will tell the calculator that our function is sine x. So enter sine x. This is sine. Press sine. Then we need to press x. X is there and the color of x is red. Alpha should be pressed, and then this button. You see that x is there. Now close this bracket. We have entered f of x equal to sine x, this function. So whenever you enter this function, you need to press this equals key. Whenever you press this equal button, you will be asked for something else. There is a fault in the software of this calculator. This option will not be there when you press equal sign, but whenever you press equal sign, the calculator will ask you that what is the starting value. So the starting value is here a. We will start from 0.0 up to 0.6. So a is the starting value, which is 0.0. Tell the calculator that the starting value is 0.0 and press equal button. So it will ask you that what is the ending value. So the ending value is b, which is 0.6, this upper limit. So tell the calculator that our ending value is 0.6 and then press equal button. It will ask you about the step size, that what is the step size. We have calculated the step size, I mean the value of h, which is 0.1. So tell the calculator that step size is 0.1 and then press equal button. Whenever you press equal button, so the calculator will tell you about the table, that this is your table. For x equal to 0, f of x is 0. For x equal to 0.1, f of x is 0.998. For x equal to 0.2, f of x equal to 0.1986. For x equal to 0.3, f of x is 0.24, and so on. So that is the table. You need to construct this table right here. So construct this table right here. This is the table. You see, this is the table. For x equal to 0, for x equal to 0, f of x equal to 0. So that is 0 and 0. We write the values of a function up to 4 decimal places. So write all those values up to 4 decimal places. You see 0.998, 0.998 is for 0.1, 0.1986, that is for x equal to 0.2, and so on and so on and so. So just look at this table and compare it with this table. These are the values. So this is the table. Now what are the values for x size? These are the values for x size. 0.0 is x0, 0.1 is x1, 0.2 is x2, 0.3 is x3, 0.4 is x4, and so on. And corresponding to these values of x size, these are the values of f i's. This is x0, so this is f0. If this is x1, this is f1, x2, f2, x3, f3, x4, f4, x5, f5, x6, f6. So these are the function values. Now all these three steps, if you are asked to compute this integral by trapezoidal rule, you must calculate these, you must perform these three steps. For all those methods, for all those rules, you must do these three steps, these three. So these three steps have been performed. Now first of all, we need to use trapezoidal rule to calculate this definite integral. And what is trapezoidal rule? That is for n is equal to 6. The value of n is 6 here. This is the formula. Integral from a to b f of x with respect to x is h by 2. In trapezoidal rule, this is h by 2, and this is actually the first value of the function plus the last value of the function. In table we see that the last value of the function is f6. So we will extend this formula up to f6. So f0 plus f6 and plus 2 times the sum of the rest of the function values. F0, after f0 there is f1, f2, f4, f3 is missing here. Yes, of course f3 is missing here. We need to write f3 here. So f3 is missing. So here we are, we have inserted f3 here. So this is a trapezoidal rule, f0 plus f6, because the table goes up to f6, plus 2 times the sum of the rest of the function values, 1, 2, 3, 4, 5, and the last one is this 6. Now we just need to put the values of a, b, and f of x in this formula to get, put the values a, b, f of x, and h and n in this formula to get this integral. A is 0.0, b is 0.6, f of x is sine of x, and h is 0.1. and to all those function values. And lastly, we need to put the values of these fi's from table. Replace f0, f1, f2, f3, f4, f5, and then f6 and this formula to get the value of this integral. We see that f0 is replaced by its own value, f1 is replaced by its own value, f2 is replaced, f3 is replaced, f4 is replaced, f5 is replaced, f6 is replaced. Now sum these values with the help of calculator. Whenever you sum these values, you will get this thing: 0.1 divided by 2 multiplied by the sum of all those values, which is 3.4902. Now multiply this with this number, you will get this answer, 0.1745. So this is the approximate value of this integral. This is the approximate value of this integral, not the exact one. What is the exact value of the function? You can calculate it with the help of calculator. How could you calculate the exact value of this function sine of x? We just need to keep this calculator in computation mode, which is 1. So this is the computation mode. We see here, this is a button which tells you people that this is the definite integral. So press this button and write the function over there. The function in our case, we see that the function in our case is sine x. That is the function. You see, f of x is, this is sine x. So write there sine x, this is sine, then x, so alpha into this button, so that is sine x, and close this bracket. Now come here, this thing, I mean you need to press upper and lower limits. Lower limit is 0.0, so write there 0.0, and the upper limit is 0.6, so write there 0.6. So we have entered this integral and calculator. When we press equal sign, we will get this answer, 0.17466. just look at that, 0.17466 and so on, and this is 0.174745, so that is 46, which we round, if we round this number, that will be 47, and this value is 45. So this value is not the exact value but approximate value, so there is error in this value. Anyways, that is the approximate value of this integral with the help of trapezoidal rule. You see, this is trapezoidal rule. Now the second one is Simpson's 1/3 rule. What is Simpson's 1/3 rule? We have studied that Simpson's 1/3 rule sorry, this slide is being repeated here, and this is Simpson's 1/3 rule for n is equal to 6. So that is the formula for Simpson's 1/3 rule, h by 3, because of 1/3, h by 3, and then because we will extend the formula up to f6 because table and because of table. So the first value of the function plus the last value of the function, this is Simpson's 1/3 rule, plus 4 times the sum of the values of the function whose subscripts are odd, that is 1, 3, 5, plus 2 times all those function values whose subscripts are even, that is 2, 4, then 6 will be there, but 6 is actually the last value. So the last value will be added with the first value, and the rest of the values which have even suffixes will be multiplied with 2. So this is Simpson's 1/3 rule, and this formula we need to put a, b, f of x and h to get this integral. A is replaced by 0.0, b is replaced by 0.6, f of x is replaced by sin x, h is replaced by 0.1. Now we will replace f naught up to f6. f6 is missing in this formula, if you see, so we need to write f6 here immediately. Here we are, we have entered f6 here, so there is the formula. Now in this formula we need to put f0, f1, f3, f5, f2, f4 and f6 from table to get this equation. We have replaced f0 by this number, f6 the last value is not entered here, so we need to enter here the last value. Okay, so I'm going to enter here the last value. Here we are, we have entered the last value of the function f6, which is 0.5646, and then 4 times f1, f3 from table, f5, f2 and f4. Now calculate this sum to get 5.2396 and multiply 5.2396 with 0.1 divided by 3 to get this answer, 0.1747. so this is the answer of this definite integral with the help of Simpson's 1/3 rule. Thirdly, we need to use Simpson's 3/8 rule for n is equal to 6. This is Simpson's 3/8 rule. That is 3/8 times h. 3/8 times h, first value of the function plus last value of the function, plus 3 times the sum of all those function values whose subscripts are not the multiple of 3, and 2 times the sum of all those function values whose subscripts are the multiple of 3. So the multiple of 3 is f3, then f6, but f6 is the last value, and we have written here the last value of the function with f0, so that is f3 only, f6 is there. So 3 times f1, f2, not f3, f4, f5, then f6 is the last value, so we are adding the last value with the first value of the function. So this is Simpson's 3/8 rule. Putting all those values in this formula, replace a by 0.0, b by 0.6, f of x by sin x, h by 0.1 and f0, then f6, then 3 times this sum 1 2 3 4 and 2 times f3. Calculate this sum and multiply it with 0.3/8 to get this answer with the help of Simpson's 3/8 rule. The third one is the second last one is Boole's rule. So Boole's rule formula for in our case is this one, 2h by 45, 2h by 45, 7 times the initial value, the first value of the function, plus the last value of the function. In our case the last value of the function is f6, so 7 times f0 plus f6, and 32 times the sum of odd suffixes plus 12 times the sum of even suffixes. Yeah, you may say that subscripts. Now replacing all those values in this formula, replacing a, b, f of x here, replacing h by 0.1 and replacing all those fi's right here to get this answer, and then calculate this sum to get this answer and multiply it with 0.2 by 45 to get this answer, which is the answer of this integral, this definite integral, with the help of Boole's rule. And the last one is Weddle's rule for n is equal to 6. This is the formula for Weddle's rule, 3h by 10, 3h by 10, remember that, multiplied by first value of the function plus last value of the function, f0 plus f6. In our case the last value of the function is f6, so f0 plus f6, then write the rest of the function values f1, f2, f3, f4 up to f5 and repeat that process, 5 1 6 1, then 5 1, so nothing is there, so up to 5. Now replacing all those values here, we have replaced f of x a b by these numbers, and we have replaced h by 0.1 and replacing all those function values from table, and calculate this sum and then multiply this sum by 0.3 by 10 to get this answer, and this answer is the approximate value of this definite integral with the help of Weddell's rule. So this is all about this chapter. All we know that there is nothing else in this chapter but the formulas.